Okay, so we're going to actually continue this video on polynomials. Okay, this is still the introductory lecture course of polynomials here. Let's talk about identifying the degree. Okay, let's talk about what the degree is. What the degree of a polynomial is. Well, the degree is simply this: the highest power. Okay? The highest power. Okay? Let's say the highest power of any monomial within a polynomial. Okay? The highest power of any monomial within a polynomial. Okay? What does this actually mean? Well, let's get some examples here. Let's say if we, well, first of all, let's go ahead and find the degree. Let's say this. We have 4a squared times b. Okay? And if I said find the degree of this here monomial, well, what will we do? The degree, we take and we make sure we add the sum of all the variables. We add the powers of all the variables in this monomial. So in this case here, we have the variables as being a, and we have the variables as being b. Now, 4 does have actually an exponent, but it's 0. So we just don't, 0 plus anything is going to give us the same answer as we had before. So we're not going to include that. So that's why I say add the power of all the variables, because these actually have powers of, if they're not given, they have powers of 1. Okay, so it'll be a, the power of a. So we'll use this, let me say here. So power of a, which is 2, so 2. Plus the power b. Well, the power b wasn't written, so if it's not written, we assume it's 1. So 1 plus 2, which is 3. Okay? So the degree is equal to 3. The degree of this polynomial here is equal to 3. Okay, let's get another here. So the more examples you see on degrees, the better you'll be with it. If I have x cubed, I have x cubed y to the 4th times z. Well, and I said find the degree. Well, the degree is equal to what? Well, let's see. The powers of all the variables. Let's add them up. We'll take 3 plus, what's the power on the y? 4. And what's the power on the z? Well, it's not written, so it's assumed to be 1. So it'll be plus 1. Which will be 7 plus 1, which will be 8. This polynomial has a degree of 8. Okay? Now, let's look here. If I gave you this constant term here, 12. If I gave you 12, and I said, what is the degree of this here monomial? Well, what would you do? All you do is, if it's a constant term, whether it's 12, 9, 8, 101, 1 million, 1,000, I don't care what it is. If it's a constant term with no variable behind it, the degree is equal to 0. That is the degree of the polynomial. Okay, it's equal to 0 because constants have 0 degree exponents. Okay, have 0 exponents. All right. Okay, let's see here. All right, so let me give you a polynomial here. Let's say we have 5x cubed plus 4x to the 5th power minus 3x squared plus 2. Okay? All right. If we look at here, we want to find, let's go ahead and find the degree of this polynomial here. Well, what is the highest power of each monomial? What did we say monomials were? Well, they're single terms that only have multiplication in between them. So 4x, 4x cubed, 4x to the 5th. These are all monomials. 4x squared y. These are what we call monomials. Okay? These are your monomials over here. So if we look here, we have this is a monomial. Let's circle all of our monomials. This is a monomial. This is a monomial. This here is a monomial, and this too is a monomial. Okay. Let's go ahead and find the degree. Now, what does the degree say? The degree says the highest power of any monomial within a polynomial. Okay. So we want to find the monomial. We want to find the monomial. We want to find. Let me see how I can say this here. We want to find the degree of a monomial, okay? And we want to know which one is the highest, okay? So we'll call this monomial number 1. We'll call this monomial number 2. We'll call this monomial number 3. And this is monomial number 4, okay? Well, monomial number 1 has degree what? Well, has a degree of 3. Okay, because 5 has a degree. We take all the variables and we get their exponents and add them. This only has x cubed here, so that be cubed. Now 5 has 0, but 0 plus 3 is still 3. Okay, so number 1 has a degree of 3. Okay, now number 2. Now, after we find all of these degrees, what we're actually going to do is see which one is the largest. And whatever degree is the largest, that is the degree of my entire polynomial. That's what I mean by this definition up here. Okay. Let's see. Number 2 has a degree of what? Well, let's look at our variables. We only have x here. So x is raised to the 5th power. So 2 has a degree of 5. Okay. Now number 3 has a degree of what? Well, x squared. So we're looking at the degree of being what? 2. And 4, of course, has a degree of 0 because it's a constant term. Okay. Well, what is the largest degree here? Well, of course, ding, 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 it's 5. It's 5. So what do we say? So we say 5 is the degree of this here polynomial. It's the degree of the polynomial. Why is it the degree? Because it's the highest power. There's no other power in this polynomial that's larger than 5. Okay? All right, hope you guys understand that example. Let's go to another example here on degrees. Okay? Let's say if I have 5x cubed yz to the 4th plus 3x squared minus 2x plus 4xy minus let's see, minus 6y to the 7th power plus 6. Okay, well, this is a large polynomial here, but let's see if we can find the degree of this polynomial. Okay, well, what we'll do, let's go ahead and let's kind of separate them here. We see the polynomials there. Remember, they're monomials. They're separated by addition or subtraction symbols. So we have this as a polynomial. I mean, as a monomial. We have this as a monomial. We have this as a monomial. This is a monomial. This here is a monomial, and we have this as a monomial. Okay, so if we look at these individual monomials, let's go ahead and write their degrees, the degree of each monomial. Well, that's equal to 0. This is a 7, so that degree is equal to 7. I'm sorry, not 0. That degree is equal to 7. Okay, this degree is equal to, well, it says x and y. Well, x has 1, y has 1, so y plus x, and 1 plus 1 will give me a 2. So this has a degree of 2. 2x has a degree of what? 1, because x is only one term, so it has 1 power degree. You know, 1 is its degree, is its power. The degree of this monomial here is 2, And the degree of this monomial is what? Well, 3 plus 4 is 7, but y has an exponent, which is 1. So 7 plus 1 is 8, so this has a degree 8. So what is our degree of this polynomial, which has the highest degree? What's the highest degree? Well, the highest degree is 8. So that means degree of my polynomial is 8, because it's the high, because this monomial here has the highest degree. It contains the highest degree. Let's say, instead of saying degree, it contains the highest exponent. Okay, this monomial here, it does. So that means that highest exponent would be my degree of my entire polynomial, which is 8. Okay. Now let me introduce you to standard form before we end this video here. I hope you guys have a good understanding of what the degree of a polynomial is. Now, standard form would be anything when the powers. So let me write it like this here so you can see. Standard form. Standard form is from anything from, let's say, from increasing powers. Now, let's not say that. Okay, here we go. From larger powers, let's use this terminology. From larger powers to smaller powers. Okay, it's in any form from larger powers. I'm sorry, that's a terrible brace. From larger powers to smaller powers here. Okay, so if I said 5x to the 4th plus 3x squared minus 2x cubed plus 4x plus 4, well, this is not in standard form because it needs to be ordered from larger powers to smaller powers. Well, we have 4, that's large. We have a 2, but here we have a 3. A 3 is larger than 2, so that means this must go before that. This and its sign must go before that in order to be in standard form, and this will go after that. Then we indeed have standard form because it goes from 4 to 3 to 2 to 1 to a power of 0. And that is actually in from larger to smallest power, which is a power of 0, right? So that is what standard form is. Let me give you another example here. If I said we have 2x squared, well, let's do 4x cubed plus 2x squared minus 3x plus 4. Is this in standard form? Well, yes it is, because we go from 3 to 2 to 1 to 0. This has a 0 degree power, that has a 1 power, this has a 2 power, and this has a 3 power or exponent. Okay, so we're going from larger to smaller values, right? 3, 2, 1, 0. That's counting down, so it's in descending order. Okay, that is what descending order is actually what the standard form of polynomial is what it says. Okay, just want you guys to understand that. Now you need to know. So basically what it is you're taking the degree of each monomial and ordering it in order of degrees. Like let's put this polynomial here in standard form at this top polynomial here. Well, let's see. We have the largest degree is 8, so we'll be looking at 5x cubed yz to the 4th. That'd be first. Then second would be this 7 here. So minus 6y to the 7th, because that has a 7 degree. Now let's look at 2. It doesn't matter which one you put first because they have the same degree. So minus 3x squared plus 4xy. Okay. Well, actually, we would go ahead and put this here first. Because since these both have individual powers of 1, let's go ahead and just put this x squared first, okay? And then we're left with this last one. I mean, not the last one, but minus 2x, which is to the first power. And then we have plus 6, which is to the 0 power. Now, this would be in standard form, okay? This is the standard form of this here polynomial, all right? Okay. Now that you understand standard forms, let's look at leading coefficients. I should have done that before standard form, but we'll do it now. Let's look at leading coefficient. The leading coefficient is simply, it's the coefficient of the first term in standard form. Now, as you know, the monomial with the highest degree goes first. Okay, the monomial, like we talked about, from larger to smaller. So the monomial with the highest degree goes first. That monomial that goes first with the highest degree, or the monomial that contains the degree of the polynomial, that coefficient that's first, that number that's in front of there, is actually called the leading coefficient. So in our example, if we have 5x cubed minus 8x squared plus 3x minus 17, what we can say here is that this goes from 3, 2, 1 to 0. So this is in standard form. Well, once I have it in standard form, I then can look at the first number, which is 5. Okay? So 3 is the degree of this polynomial here. 3 is the degree. The degree is equal to 3, and the leading coefficient is equal to what? Well, 5, because 5 is the leading coefficient of 5 is the coefficient of this first monomial here. Okay, so that's how you identify the leading coefficient. This stuff is really very simple. As soon as you see it enough, that's why I'm not really going in depth with it, because this is just a very simple topic. Nothing more I can really say about it. Let's take 4x to the 4th power plus 6x to the 6th minus 2x plus 4. Okay, if we take this polynomial here, we see that this is not in standard form because 6 is larger than 4, but it comes after it. So in order to identify the leading coefficient and the degree, let's rearrange this in standard form. It'll be 6x to the 6th plus 4x to the 4th minus 2x plus 4. Okay. Well, now that this is in standard form, from increasing to decreasing, so in descending order from larger powers to smaller powers, we can go ahead and identify our leading coefficient. Okay, so our degree will be 6 because it's the highest degree here, right? 6, this is 6, this is 4, this is 1, this is 0, so 6 is the highest degree. And the leading coefficient would be what? Well, what is the coefficient of this this highest degree monomial? Well, it's 6. All we do is look at this first term. Once it's in standard form, we just look at this first number. Okay, that first number, and that's the leading coefficient, which is 6. So if it's in standard form, all we do is look at the very first number. Okay. Now, this is going to be a long video, but this is our last topic here. We're doing classifying polynomials, okay? I'm just trying to fit this in here so the next video I can start it with subtracting. Let's classify the polynomials here. Well, we have a constant, which is, I'm just going to go through this quickly here. We have a constant. The polynomial is called a constant when it has, let's get a chart going here. Well, we can do it like this, constant. A polynomial is called a constant when it has a degree of 0. It'll be best to go ahead and give you a chart just so you can understand it a little bit better. Let's see, that we'll put name here. We'll put degree. Put name and degree. Okay. So it's called a constant. The polynomial is called a constant when the degree is 0. Alright, the polynomial is called linear. Called a linear polynomial when degree is 1. Okay, it's called a quadratic when the degree is 2. It's called a cubic when degree is 3. When the highest degree of this polynomial, when the degree of this polynomial is 3, it's called a cubic. When it's called a quartic when degree is 4. And it's called a quintic when degree is 5. Now we do have things that go beyond this, which are like your sectic, your spectic, your octic, your nonic, but we won't go that far. We'll stop at 5 here because you usually don't see them past 5, but we'll just stop at 5 here. Okay, so this is how you classify the polynomials by their degrees. Constant when it's 0, a linear when it's 1, quadratic 2, cubic 3, quartic 4, quintic 5. Okay, so we've covered a lot in this video here. We've covered a lot. I hope you guys are understanding this thing with degrees and leading coefficient, and understanding all this stuff that we just went over in this video.